All right, to introduce this concept, it's going to help to have another definition that I haven't given you yet. So here's a graph. We've been talking about things like shortest paths. So let's look at a path from A to G. So here's a natural path to choose. It's one of the shortest paths from A to G, but it's by no means the only path from A to G. So here's another path from A to G, A to B to E to D to A to B to E to G. It's a path. It's going from node to node, crossing edges, but it's not a simple path. So a simple path is not allowed to have any repeated nodes. Any shortest path is going to be a simple path, right? Why? Because if we had any repeats along the way from A to G, if we visit B and then sometime later we go back to B, then there's going to be a path that just goes from A to B and then using this path from B to G. We don't need any of these links in between. So if a shortest path actually had on it a repeat, it was not a simple path, then it can't be a shortest path. There must be a shorter path still. So that's a contradiction. Now the longest simple path that you can have at most n nodes on it, because there's only n nodes in the graph and we're not allowed to repeat any. So the longest simple path is of length n. This graph has 7 nodes. So let's ask a question having to do with this graph here. I want you to check the boxes, each box with number k next to it, if there is a simple path of k nodes that goes from A to G. So, for example, it can't be 1 because it has to have at least A and G on it. And we already saw a path A, B, E, G that's a simple path that has 4 nodes on it, so we'll give you 4. For each possible length, check the box if there is a simple path with that number of nodes on it from A to G.